I am the Science, Technology, Engineering, and Math Outreach Program Manager at iRobot, which basically means I'm in charge of all of iRobot's educational outreach initiatives. And Maya graciously invited me in. So I'm going to be telling you about how robots are taking over the world of education. This is a different type of talk than folks from iRobot normally give. We normally don't talk too much about taking over the world this way. But it's a lot of fun. And if at any point you have questions or you can't hear me or something goes wrong, just let me know and we'll go from there. So I have been at iRobot for about a year and a half now. Before that, I got my master's and Ph.D. in robotics from Carnegie Mellon. I worked with Ela Nerbash and David Wettergreen, which was a lot of fun. And before that, I got my bachelor's in computer science from the University of Minnesota. So I kind of started out in software and then moved over into the fun of robots. And that's where it's carried me today. I first want to tell you a little bit about our company, and then we'll kind of get back to this whole robots taking over the world issue. So iRobot, many of you may have heard the name, right? We're a robot company. This is actually our mission statement. So the first thing at the top, I apologize for the lack of contrast, is build cool stuff. Who here believes that robots are cool? Yes! Excellent. You've come to the right place. So we think robots are really cool. But not only is building them fun, we want to make sure they're actually useful and helpful to people. So that's why the second line in our mission statement is deliver great products. So not only are robots cool, but we're building tools that are practical, designed to make people's lives easier or to keep them safer. Additionally, we are a publicly traded company, so we like to make money. We do our best. And the biggest line, have fun. I believe Google also has much of the spirit of having fun, so we definitely believe that. Robots are cool, we have fun making them. And we try to change the world. And in my case, I'm trying to do that through educational outreach. Again, just to give you a quick reminder or let you know about our products, so on the left is the Roomba robotic vacuum cleaner. That's one of our signature products a lot of people recognize. The one on the right is a PackBot that's made by our Government and Industrial Robots division. Those are used out in Iraq and Afghanistan for examining potential improvised explosive devices. They'll send them into caves to do cave clearing. But in addition to those two, we have a whole other suite of products. So we've actually sold over 5 million home robots to date. So we've got the floor washing, vacuum cleaning, gutter cleaning, pool cleaning. We've also got a number of other ground vehicles. We do some maritime robotics as well. So a lot of different cool things happening on the robot front. But what I'm actually here today to talk to you about in particular is the idea of robots taking over the world. So when you think about the robot apocalypse, what kinds of images come to mind? Anybody, shout it out. What do you think of? Come on. I know you have watched science fiction movies. What does the doom and gloom future look like?
Destruction, horror.
Yes, destruction, horror.
Terminator.
All right, I know we're just warming up. We'll get into it. Right, stuff like this, right? We've got Terminator, Fender, the sort of robot uprising phenomenon, right? That's sort of the science fiction, what we imagine the horrific robot future will look like. My argument today is that this is not, in fact, what the horrific future is going to look like, at least not as far as I'm concerned. It's going to look like this, right? Kids all over the country and all over the world building robots, programming them, having fun, and learning a lot. Right, so this is what we're actually here to talk about, is a number of the programs, cool technologies that we're seeing kind of spread throughout the educational system. And then we're also going to be talking about some of the challenges to any would-be educational robot platform in successfully taking over. So why should you support this robot uprising? So the main argument one of the main arguments we talk about is the fact that the United States in particular is falling behind in the number of college graduates who are entering science, technology, engineering, and math fields. According to some recent estimates, we need 400,000 new STEM grads by 2015. This pie chart shows what we're actually currently working with. On the left, there are about 2.5 million seniors who graduate from high school in the US every year. Out of those, only about 35,000 will enter college and get a STEM degree within 6 years. That's about 1.4% of the total high school population. this is clearly not going to meet our needs in terms of jobs. You know, in order for America to remain competitive, right, we need kids to go into these fields. And so we found that robots are a really great tool to get kids hooked, to get them excited, start teaching them these concepts, and bringing them in to the STEM fields in college. Why robots? As we said before, robots are cool. I have really yet to meet a kid who's not captivated by a robot sort of moving around in the environment, doing stuff. And so that's really exciting. So seeing robots, kind of the idea of robots is appealing. But then when it actually gets more interesting is we've got a lot of connections between, you know, robotics and the physical world. While there's obviously a lot of cool stuff you can do with computer programming and video game programming as ways to get kids interested, the physical component of a robot is very compelling, we find, in a way that it's just not quite the same as other technologies. Robotics has many real-world applications. So again, we have something where we can show the kid, hey, you know, all this math and science, you have to take these classes, what can you do with it? Well, you can bring out the device and you can show them, hey, you know, we have millions of these in people's homes, or, you know, we've been deploying these overseas, or we're collecting data in the ocean. Like, all those kinds of things. You can really show them and make that kind of connection. When I talk to teachers, one of the things they tell me that's the most valuable is being able to show this kind of application to their students, because it makes the work that they're doing in class, you know, mean something, and makes it seem a lot more valuable. Additionally, because robotics is a multidisciplinary field, kids get to learn a lot of different skills, right? You get to start working with mechanical engineering, electrical engineering, computer programming, but there's also skills involving teamwork. Because you need all these different disciplines, ideally, you know, it takes lots of people with lots of different strengths in order to build a successful robotic system. And these are really valuable skills that we want students to start learning early in their careers. So we've got some cool problem solving, we've got real-world applications. Are a couple of the reasons why we find robotics a particularly exciting technology to use with students. So how is it that the robots are making these advances? What tactics are they using as they advance to take over in education? One of the things I wanted to highlight is just the sheer number of robotics platforms that are available today. It's really amazing. These run the gamut from kits that are really based on construction and putting things together. So, for instance, Lego Mindstorms, right? You've got your components, you're going to assemble them into a robot, you'll add sensors, you have a board for programming. So you've got this kind of kit approach, kind of on the one hand. On the other side of the spectrum, you have robots that are basically self-contained, so they're already put together, and kids can just get right away into the programming them, having them do tasks and competitions. So there's a really wide variety of platforms. I can also say that can almost be an advantage and a disadvantage for teachers who are just starting to get started in robotics. It's not always easy to know kind of where to begin. But this kind of variety, I think the sheer options that you have can be a real strength. The other thing that I really didn't start to appreciate until I came to this position at iRobot, there are tens of national and international robotics competitions and challenges for students these days. These are just a few. These are some of the folks that I've worked with in my capacity. So we've got FIRST, of course, is very well known. Dean Kamen's program that's over 20 years old now. RoboCup is a generally collegiate competition with RoboCup Junior as an alternative for K-12 students. So there are lots of options. We've got some of these are marine, underwater-based robots. We've got some that are more focused on programming, some that are more focused on machining and building. But in terms of the sheer number of opportunities for students to get involved, this is really exciting. I also wanted to let you know, so one of the other really innovative things we've started to see now is very cool curriculum. So when I say curriculum, I mean sort of the activities that go along that would lead an instructor and students kind of together down a path of learning about robotics and accomplishing some tasks. So there's a couple of cool things I wanted to point out. This example, so this is some work done by a teacher named Steve Cogger. He's a middle school teacher in the Boston area, where I'm from. And Massachusetts actually has engineering standards, so students are required to gain some engineering knowledge. And he has designed a robotics course that every student in his school will have to take. basically in their 7th grade year in order to meet their engineering requirement. And so the kids basically build their own RC vehicles. So we can discuss whether or not this is actually a robot. He's getting to adding more autonomy in future iterations. But you've got this idea of constructing. So every student every team of 2 students in the class is tasked with designing and building a robot to do some task. So the one on the upper left, that's got a plow that will raise and lower so it can push things around. We've got an artist robot in the bottom left. And so this gives kids an opportunity to be creative. They exercise the engineering design process, right? So it's come up with your idea, think about your constraints, come up with your design, build it, test it, and keep iterating. And so this kind of development where it actually addresses school standards is really important, and we'll talk some more about that in just a minute. Another curriculum that I wanted to point out that I think is really exciting is called Robotics. This is a program developed at the University of Massachusetts Lowell and the Revolving Museum. And in this program, kids are not building the sort of traditional mobile robot. They're actually building kinetic art. So these are interactive art pieces. So the kids work together on an exhibit, which is shown at the museum. And you've got things like the sculptures, the white sculptures in the background. They react to light, they react to sound, they react to touch. So the students are using sensing. They've got microcontrollers that they're programming, and they have actuators that are driving servos and motors. This is all the components of a robotic system, but in a way that's very creative. And this tends to appeal to girls and underrepresented students who don't normally see themselves as robot builders. They don't, immediately see some of the other competitions and think that's what they want to do. This is a very creative way to get kids hooked into robotics, into that very tangible experience. And that's been a really successful program there. All right, so I don't always create robot armies, but when I do, they fail to take over the world. So sadly, while there's been a lot of exciting developments in terms of educational robotics, the technology that we have available, the number of competitions, there are a number of challenges that prevent the true world domination that we would really like to see. All right, one of these I call multidisciplinary chaos. So robotics itself as a field is very multidisciplinary. And what you'll find, especially in universities where folks are developing these kinds of activities, is you'll have folks from computer science who are working with robots, using them to teach programming concepts. You'll also find folks in engineering departments who are also using robots. They tend to be more on the, say, mechanical or electrical engineering departments. And again, getting kids to really build and fabricate robots. And these two groups of people I found don't always talk to each other, right? They don't necessarily operate in the same circles. They're not publishing in the same conferences. They have different sort of groups of K-12 teachers that they're reaching out to. And so that can be a challenge to help kind of bring people together. Additionally, so besides you've got kind of folks in these departments, there are some people who specialize in education research, right? So they're going to develop a program. They want to evaluate it to make sure, what are the kids learning? What are we getting out of this? Whereas for other faculty, it's a service activity. So, I'm going to host this robot competition. I'm giving back to the community, which is great. But there's this challenge of how do you make sure that your programs are kind of rigorously evaluated, that you're actually having the kind of impact on learning that you want. Because again, these groups aren't necessarily talking to each other. Additionally, we find work on robotics education at schools of education and at psychology departments that are doing learning research. So these are folks who may be collaborating with folks in computer science or folks in engineering, but you may not be getting that overall connection. Then if you start looking at bringing things down to K-12, K-12 teachers tend to be very specialized, at least at the higher grades, I'll say, maybe not so much at the lower grades. So you've got here teachers who do science, math, engineering, computer science teachers who may or may not be a subset of anybody else, and technology teachers. These are the folks who used to do like VOTech, like manufacturing type skills. They're trying to now use robotics to give their students kind of a more modern curricula. So all of these teachers have their own teachers associations. They have their own networks. You've also got to consider sort of boards of education and the administrators need to get on board in a district, for instance, to bring something like this in. So groups of people who are excited and starting to do things, but we may not be making all the connections. The fun continues. So outside of school, in what we call informal learning settings, so these are things that happen after school, summer camps, on weekends, museums and science centers are now starting to offer more robotics classes and curricula, makers and hackers. So people who like to build and tinker with stuff are often doing very cool things, like with the Arduino microcontroller, we've seen a lot of use. So they are maybe doing some relevant things, and then of course our nonprofit space. So you saw all the like dozen, national robotics competitions. Most of those are run by nonprofits, which you see sort of some ins to some parts of the community and not others. Then there's industry. So a lot of companies, in addition to iRobot and Google, are trying to support these efforts. So you've got folks from the tech industry, folks from the defense industry, who are particularly concerned about getting American students in STEM because they're trying to hire people that can have the appropriate security clearances. Folks in manufacturing who are trying to sort of grow and help modernize America's manufacturing industry. And then there are a number of companies that just do educational robotics. And this is one of these, like, I've been invited on a number of kind of committees for these different groups, and every committee, like, subset will get together and be like, we should all unite and have a common front. And like all like 5 committees are saying that like separately. So this is really, it's a big deal. So trying to kind of bring everybody together can be really challenging. And there is a lot of great work going on, but trying to connect all those dots and help everybody know what everybody else is doing is really hard. The next major challenge that our robots face is standards-based testing. Why is that a concern? In part because every state has their own set of educational standards. So if you want to get a robot in a curricula, you have to basically fight a battle 50 times. So we've seen a relatively low use of robotics during in-school time on a large scale. There are a couple of ways you can start to get around that. There are some national standards that are being adopted in math in particular. So you'll have states that are more likely to borrow from a common set of math standards. So I would kind of argue if you want to get in school, math is one way to do it. Use robots as a tool to teach math. There's now a movement to argue that computer science should be counted in high school towards like graduation credits. It should be counted either as a math or a science. And that would be another way to kind of bring robots in, since robots and computer science are a natural fit. Being able to make sure students can actually count taking robotics towards graduation would help a lot. Kids have very full schedules. They have a lot of stuff they want to do. And so you need to, we want to help make it easy for them to take robotics and have these experiences. And so it needs to count. Teacher training. This is a challenge that I've become more familiar with. So especially at the K-12 level, a lot of teachers don't have the training or the expertise to really be able to use robotics effectively in their classrooms. At the elementary level in particular, a lot of teachers don't feel very comfortable doing a lot of science and math. And so making sure, like, it's one thing to sort of have a bunch of robots and kind of give them to a teacher, but if the teacher isn't prepared to use them, doesn't know how to use them, maybe doesn't have the programming background or expertise, it's really challenging. So you have to almost, get out to the teachers, make sure they're well trained. You want to get out to the schools of education that are training the teachers, so your upcoming teachers that you graduate will have the skills so they can go out into their classroom and use robotics. So that's kind of another piece of the puzzle to consider. Another challenge, so as I mentioned earlier, there's a whole slew of different platforms that you could potentially consider using with students. And so knowing sort of what's the right platform given what you actually want the kids to learn, there's the issue of documentation. So some of you may be aware that, like, once you've actually done something, writing up all the documentation just isn't that much fun. And so for a lot of teachers, for instance, a teacher may do something cool in his or her classroom, but then not really have the time or resources to document it in a way that other teachers could replicate. At the university level, the folks who are doing cool programs again, may not have the time or funding to make sure that they're packaged in a way that's easy for a teacher to take and replicate. There are certainly some good examples of this. The Center for Engineering Education and Outreach at Tufts does a really good job of packaging up curricula. But this is really a challenge, right? It's not just enough for you to go out and offer 30 students a really awesome experience building robots. But really, right, we want to make that a kit so we can distribute it, and any classroom can pick it up, got your checklist of materials, know what you're going to be doing in each class session. That's really what you need to see. That not only helps your dissemination and reaching more kids, but it helps the teachers because they'll have the tools and they'll know what to expect, and they can bring their students into the lesson. Evaluation. So evaluation is the question of, what are we actually doing? Are we actually having an impact on students by giving them this technology? And so educational robotics as a field has been around for more than 20 years, starting out of early work at MIT. And the jury is still kind of out. We believe they have a good impact. There's a lot of anecdotal evidence. There are the concrete studies that are really well designed and have statistical significance are unfortunately few and far between. This is in part because, again, a lot of the folks getting into robotics with kids may or may not have the training in experiment design and really have expertise in doing that kind of learning research to show that the kids are learning what you want them to be learning. Because if you want to go after money for a robotics program, you really want to show that it's having an impact. So you want to show that the kids are gaining knowledge and skills of tools, of processes, immediately after a program. Ideally, you would want to watch the kids long term and see what happens. Do they actually go to college and major in a STEM major? Do they graduate with that major? What career do they go on to afterwards? And this is a challenge because of a number of child safety and privacy laws. So that's understandable. But it makes it really hard to show the kind of long-term impact that we'd like to see. And finally, money. What does it all come down to? A challenge of working with robotics in the classroom, while it's really cool and tangible and fun, it's expensive. And for a lot of schools, that's a major obstacle to acceptance. So you'll see, private academies will maybe tend to be more invested in robotics programs than otherwise. It can be really hard to round up the funding. I know of some teachers that, will go into their own pocket to try and get something for their students that they need. But this is really hard. So the availability of a really low-cost, robust platform is a barrier. It's a major challenge that we have to think about. So altogether, that's what you've got. So yeah, it's unfortunately educational robotics is not as easy as just taking a robot kit and giving it to a kid. There are the factors between sort of the broader community, connecting people's work together so that we can use it effectively, figuring out the right platform at the right cost that meets some educational standards. It's a lot to think about. It's a fun problem to be working on, however, I will argue. So you can kind of simplify it down into these, kind of 6 items. And ideally, you want all of these things to be aligned. So you want, for instance, your objectives, which would either be perhaps from state testing or other sort of knowledge objectives that you want your kids to do. You need to have those identified, and those need to line up with the curricula, right? The activities that you're actually having the kids do should ideally have a direct correlation to what the outcome you want at the end. You need to incorporate instructor training, whether it's for teachers or out-of-school time instructors. They need that background. You need to incorporate evaluation, so checks to make sure, are you actually having the impact you expect to be having? You need to have the right technology, so the right platform or kit for the application that you're interested in. And you need to consider, as much as you can, kind of the various stakeholders, the web of folks who may be involved and have an interest in deploying robots into a given school or after-school program. And ideally, while you do this, you don't want to forget the students. Ideally, we should really be very student-centered, whenever possible, involving kids as much as we can, not only as participants, but where you can, as organizers, as inventors. I think it's really easy to sort of underestimate what kids can do. I think as adults sometimes we don't give them enough credit for having the kinds of cool ideas that they have, and so trying to keep the students at the center and let them remain our focus is really important. So that's sort of the problem space. And I'd like to now tell you a little bit about some of the things that iRobot and other folks are doing to sort of get into these pieces and see what we can do to promote robotics in education. So I'm in charge of iRobot's educational outreach program. It's called SPARK, Starter Programs for the Advancement of Robotics Knowledge. We have a website, spark.irobot.com, where we try to pull together resources and activities for parents, teachers, and students. So information about a variety of different robot platforms, you know, the ones that we make, the ones that we don't make, you know, any kinds of online activities, any tools that we can provide. We've got some articles that are from various folks doing different kinds of robotics projects as kind of exemplars to give people ideas. You know, here's what different people are doing around the country. So trying to kind of build where we can a go-to place for educational robotics. I'm also a leading organizer of National Robotics Week. Thank you to all the folks out who've already been involved with this, and I know the team in the Bay Area is going to be doing some cool stuff for National Robotics Week. So this is an initiative that started last year, and it's a partnership between iRobot, a number of other companies in the industry, some museums and science centers. We're working with the Museum of Science in Boston, the Museum of Science and Industry in Chicago, for example, and universities, so a number of folks who do either outreach or robotics research. And so we're coming together during the second week of April to both sort of raise general public awareness about what robots are and what they're doing right now, but also as an opportunity to showcase what kids are doing with robots, to provide kids opportunities to get hands-on robot experience. And so the first year, let's see, do I have that? I do. So 2010 was our first year. We had over 50 affiliated events in 21 states, DC and Puerto Rico. We estimate we reached over 46,000 people, including over 24,000 K-12 students. So we're really excited for our first year, very grassroots, to get that going. So we're now building on this for 2011. The Boy Scouts are going to be releasing their new robotics merit badge during National Robotics Week this year. We've got some new partners, so we're really excited. So nationalroboticsweek.org, go check it out, see if there's anything going on in your area. If not, organize something. Basically, anybody who has a robot-related event can go online and submit the event, and we get it up on the calendar. So really a way to just kind of generally kind of cross-promote and raise awareness about robotics in education. Additionally, iRobot is the manufacturer of the Create platform, which I know some of you are intimately familiar with. So this is essentially a Roomba without the vacuum. So it's a programmable mobile robot base. And the idea is that it's got some kind of fixtures so that you can kind of bolt onto it, so you can kind of expand it to make the robot, you know, to make a robot that does what you're interested in. The students on the bottom left, they're from BotBall. That's a national competition. They give every team a kit containing a Create and a bunch of like Lego parts and some Vex parts, and the students build robots with it. We've seen them used in university research labs, so you can basically slap a netbook on top of one, and then you've got kind of a little mobile robot platform with a camera. Some other more advanced work out of CMU developing a low-cost arm to give it some kind of manipulation. So this is kind of our platform that we have available to folks who want a way to sort of get started in the robot space. Additionally, we help organize a teacher workshop every summer. It's called STREAM, so we're integrating robotics into STEM. So we add the R in there, and then you throw in an A so you can pronounce it, and you get STREAM. And this is a 2-day workshop where we invite 50 teachers out to our headquarters, and we have teachers who are already using robots in their classroom present to other K-12 teachers. So, you know, here's an activity I do with my students. This kind of teacher-to-teacher interaction is really successful. We get great feedback on that, and it's a very kind of practical way for teachers to see, oh yeah, you know, I could do this. So we're gearing up for our 2011 workshop. And then our employees at iRobot are really excited to be involved, so I help train folks to go out into schools, give talks and demos. We invite students to come out to our headquarters for tours, so we reach, you know, hundreds of kids come visit us at our headquarters, and our employees reach thousands of kids every year by going out and kind of showing them firsthand, hey, you know, this is what our company does, this is what I do, it's cool, you know, you should do it too. And that's been a really fun program to be involved with. We're certainly, by all means, not the only group, you know, interested in using robotics as a means to promote STEM education. So a couple initiatives. So Google is involved with the folks on the top row there. So there's computing in the core. This is an initiative to have computer science count as either a math or science credit in the States. There's the National Center for Women in Information Technology, which is particularly focused on how do we get more girls and young women into computing and related disciplines. And Computer Science Education Week, which is, gosh, it's in December. And so that's another time to really kind of focus on education. And that's now, I believe, run by the Computing in the Core folks. There are a number of other big national initiatives. The National Lab Network, which is formerly President Obama's National Lab Day. But the National Lab Network is trying to provide, trying to link together opportunities so you kind of go online, figure out if there's anything STEM related in your area. Similarly, Connect a Million Minds, that's Time Warner's initiative. Again, trying to kind of compose this giant event calendar of opportunities so that you have somewhere that you can point kids. So if you want to get involved, if you want to join the Robopocalypse, which I know you do, there are a few things that you all can do. So one of them is really just taking the time to talk to kids. Maybe they're young kids, maybe they're a school that you want to go out and visit, but showing kids the kind of real examples of what you are, what Google does, what you do, that's really important. Part of the challenge that we have in getting kids into these science and technology fields is a lot of them don't have those kind of role models either at home or at school in their daily lives. So I meet a lot of kids who don't know what an engineer is. They don't know what a programmer is, right? They're around, their teacher, and they go to see the doctor. Like, these occupations, kids are pretty familiar with. But once you start getting into engineering and computer science, kids need to actually see and meet somebody that really does this, and it makes a huge difference. Please take a look at National Robotics Week. If you've got kids, or just in general, if you like robots, check it out. We would love to have you involved. Additionally, specific to Google, if you're interested in doing more with robotics, consider contacting Ryan Hickman and joining the Google 20% Robotics Task Force. They've been putting some really cool stuff together, which I will hopefully be able to show you in a minute. Or if you're more interested in sort of educational outreach opportunities at Google, you want to reach out to Susie DiPianto there. I've been talking with her a little bit, so she offered to be the contact person. So if you need more ideas, you want to find out more about what Google is doing or how you can get involved, please get in touch with Susie. So that's where we're at. So again, I'm Kristen Stubbs. You can reach me at kstubbs@irobot.com, or check out our Spark site. And clearly, ending your talk with a meme will definitely make it more respectable. So thank you all very much. If you guys have a minute, I want to go ahead and do a quick demo of the Cellbots application. So this was created by the 20% Task Force this past October. Without my robot. So this is an iRobot create. Oh, sorry, folks in DC, you probably can't see. So it is essentially a Roomba without the vacuum, and we have a payload bay that you can fill stuff. We make a Bluetooth module, and this is what a lot of folks use, particularly in K-12 education. To talk to the robot, it's much easier than trying to deal with the serial table. All right, so yes, for those of you who don't know, this is a create. It's like a Roomba, no vacuum, big payload bay, Bluetooth module. So the Cellbots application is really cool, and it can do a number of interesting things. The most obvious one that I'm going to try and show right now is just to do simple remote control of the robot. There we go. Yes. Oh, sorry. So there's a number of different joystick modes, all kinds of cool stuff. So I believe, Ryan, is anybody on Android, 2.2 and higher? Can you use Cellbots?
Yeah, 2.2 for the video streaming, and we might make a 2.0 compatible version that drops the video stream.
Cool. So it's kind of one very simple option. Then additionally, if you've got yourself a car dock, you can mount the phone. I only have one phone on me at the moment. You can mount the phone on there, and the robot will stream back from the camera on the phone. So then you could be over the internet or on another phone and be controlling the robot and walking around. It's very cool. If you check out cellbots.com, they have a video that goes through like all the stuff that the application can do. and it's very cool. But this is just a really easy way to get started. So it's compatible with the Create, with Vex, with Lego. I'm probably missing one. Those are the three major ones. But this is a lot of fun. So this is some Googler effort that I was privileged to be at least peripherally involved in supporting. So that's our platform. All right. So I am now open for questions. If anybody has anything, please speak up.
So what is the target of the kids? What age group are you usually be interested in teach the kids?
Okay, so the question is, what age group might we be interested in reaching with robotics? So traditionally, most work I'd say there's a lot of stuff available in high school. A lot of the big competitions are geared towards high schoolers. They're starting now to see some more work into middle school. And there's data that suggests that especially for young women, middle school is kind of the time where they decide whether or not they want to do a science or technology career. So we're starting to see more effort to get down into middle school and to give more middle schoolers the opportunity to use robotics. Certainly at the college level, there are a number of programming, like CS1 intro programming courses that are now starting to use robots. So we've got kind of college, a lot of stuff in high school, some stuff in middle school. There's starting to be a little more work in elementary school. There was a project out of Tufts University to create a tangible programming interface, and they're actually had developed some work. So you had preschoolers like stacking up colorful blocks, and they would take a picture with a webcam, and the blocks were like go forward, go left, go right, and the kids can stack them up, take a picture with the webcam, and then the robot does it. It's the coolest thing ever. They have like kindergartners programming robots. So I believe that basically you can never be too young, within safety constraints and all that. But I'm all for going younger, getting kids hands-on with robots as soon as possible. Good question. Anything else?
One of the robots you had on one of the slides looked like a dog with a really long tail. It was kind of blobby, colorful pieces.
Oh,
what is that?
That's Topobo. T-O-P-O-B-O. That's Topobo. That was out of MIT Media Lab. Oh, is that right? Or is that CMU? Oh, gosh. All right. I'll get back to you on exactly where it's from, but it's Topobo. And, oh, thank you. And so that's a really cool set because you plug the modules together and they basically interact through that physical connection, so there's no additional computer or programming required. It's this kind of emergent behavior type property. The one above that with like the stacking blocks is similar. You basically there have some blocks that are sensors, some blocks that are actuators. That's called Modular Robotics is the company that does that, and that's a similar thing. So you've got a sensor block, a block that does some kind of computation, and then an actuation block. So you've got your light sensor, and the computation block says, if I get a high signal or if this is on, then activate, and then you've got your motor. So there, again, it's this kind of like you develop the program through the physical structure of the robot. Yeah, it's really neat stuff. Yeah.
That especially seems fairly far removed from programming and even further removed from the ways that kids are asked to express themselves mathematically. How can you bridge these gaps, especially for middle school and younger?
So that's a really good question. So with some of these sort of tangible interfaces, isn't that kind of far removed from what we want students to do on tests, or how do we kind of connect that to larger disciplines? That's a really good question. I'm not entirely sure I know the answer.
I would think that it's good because the thing is it's teaching the kids the critical thinking skills that they would eventually need to move into what's more considered standard computer programming.
Okay, so that makes sense. So maybe, you're teaching them sort of logical thinking, critical thinking skills, design skills, this sort of trial and error. I mean, that's something you kind of have to teach kids, that like it's okay to try something and make a mistake and fix it, that kind of iteration. So it may be that you're teaching some of these other skills that could then potentially feed into the kind of more traditional sorts of paper and pencil type stuff. I don't know.
I guess I'm worried about the fact that kids are going to decide, yeah, sure, these robots are fun as far as they go, but I'm still bad at math. And I hear I'm bad at math a whole lot.
No, that's, I mean, absolutely, that's a valid concern. That's something that, I think that's part of the challenge, is making the good connection between sort of what you're doing with the robots and sort of the other subjects that you're supposed to be learning. I mean, that definitely has to be very well articulated in the curriculum. And I think there are some folks who are trying to make that very explicit. But, you know, like I say, it's a whole big diverse group of people that are kind of attacking the problem from different angles. But no, that's a very good point.
You mentioned that the price of robotic models is one barrier. What price usually?
Oh, sure. So the question is, if you know, saying that cost is a barrier, what kind of price range are we looking at? It depends on the kit. If you want, so I know the Boy Scouts are actually currently hunting. They're trying to find a kit that's under $100 that involves some building, and it's not just like snap the parts together. They haven't been able to, like, I don't know that they found anything yet. For under $100, you can potentially get a small programmable robot. So the Finch, and there's another one on there. So that's maybe $100. You don't want more than about 1 or 2 students per robot, I would say ideally. Because once you start getting into groups of 3, somebody's not doing something. So it takes a lot of them to outfit a classroom. Lego Mindstorms, which is very popular, those are around $250 a set. The Vex kits, those are really heavy duty. They're used in some of the high school competitions. Those, a classroom set starts at around $600.
How much is a robot? Those are cheap. It's like 120 or something.
Yeah, Bobots are closer to like 120. And there's always these kind of trade-offs between how freeform is it, right? How much kind of construction are you doing? How many sensors do you have? How many motors do you have? So there's this whole kind of spectrum. And part of it kind of depends on what subject or what learning goals you're trying to meet. But yeah, so that's kind of the ballpark. Like most commonly, like I say, Lego Mindstorms is now the most common. That's about $250. And again, maybe you can have 2 or 3 students on one set. But yeah, no, good question.
Yeah, I have a question here in Pittsburgh.
Sure.
So I guess sort of the impression that I've gotten about a lot of the in-school robotics is that a lot of it's, and I'm not talking about the after-school programs, but sort of the in-classroom stuff seems like the idea is to have sort of a one-time experience being, you know, facilitated by someone who doesn't really know any more about it than the students do. And I guess it's not completely surprising to me that that's something that, you know, hasn't really been, you know, overwhelmingly shown to improve the curriculum. And I guess, you know, is there anything that we can do about that besides, you know, having teachers who, you know something about it and doing the same thing we do for all other subjects, which is have the teachers know more than the students and doing it for an extended period of time?
Yeah, I think I would definitely agree. The kind of one-hit experience, it can be good to kind of inspire students, to get them excited, but in terms of the sort of long-term learning impact, yeah, you're not going to see as much. Like I say, when you're talking about getting into schools, it's about standards. You know, can we have a good curriculum that teaches, you know, pre-algebra that you know that uses robots as kind of a teaching tool? Like I feel like, at least from what I've seen, I think that's the most likely to get it in. Is if you like I say, if you're going to be in school, you have to deal with the standards. Unfortunately, there's just no way around it. So ideally, I'd like to see kind of more documentation and more teacher training around that kind of program. Whether you're using robots, you know, in your math class, in your technology or engineering class, in your computer science class. I think most likely that's kind of the direction you'd be looking, is how do you make an actual whole, you know, semester or year-long course, and yeah, how do you get the teachers comfortable enough to actually execute that kind of course? That's where you'd be looking to see more of those long-term gains.
But even in computer science, most of the high school computer science teachers, most of them are, you know, retread math teachers or something. And mostly they're just trying to teach a language. They're not really teaching computer science. So it's not entirely clear that that's the answer either.
So there is now an effort underway to revamp the AP Computer Science curriculum so that it's not so language focused and it's more focused on computing concepts. And so that's being led by Jan Cuny at the NSF. And they're working in partnership with the Computer Science Teachers Association. So I think there is starting to be more of a move towards actual concepts as opposed to the kind of specific, we're teaching our kids C++ or we're teaching our kids Java. So I feel like there is some hope in that direction.
Thank you.
Thanks. Anybody else out in VC land? Anybody else in the
What language do you use to program?
So the question was what language is used to program the create? So the create, basically we publish an interface over serial that's like literally here's what bytes you put out over serial and here's what will happen. Based on that, folks have developed environments for it in Java, Python, MATLAB, Alice, a number of different things. So yeah, the underlying stuff is just serial, and then it's kind of the next layer up. You can decide what you want to do.
So basically, there are no brains in it. There are no brains in it. You just have to. Right.
Are there no brains on it? Well, there's a very limited amount of brain power on the robot. It can accept, a few lines of this kind of stream of serial bytes that you can then run on board. But yeah, usually you'll either plug in the Bluetooth, you'll run it, off board, or you'll put something like a microcontroller or a netbook on it and do your computing that way. Yeah, it is not a computational powerhouse by any means.
I have a question.
Sure.
Yeah, so for the Lego Mindstorm thing, so by default it comes with the software called LabVIEW variation. So by which age should I try to teach kids to use other language rather than this quite strange, not really a language?
All right, so the question is, so Lego Mindstorms comes with LabVIEW, which is from National Instruments. At what age, do you want to move kids on? That's probably a very it's loaded question. There are certainly folks who would see that from a number of different perspectives. I really think that, there are so many languages out there now, like Alice and Scratch, that you can get, younger kids working with those up into Java, even into like middle school. The ball program that uses Create, those kids use a variant of C called KISS-C, and it's basically C, and they're doing that at middle school, and they're fine. So I think it's more a matter of, do you have a good curricula? And if you have a good curricula, yeah, I'd say age is not so much your limit. So again, sorry, I don't know if that's a great answer, but that's what I'd say. So again, give kids some, kids can handle a remarkable amount. You give them the tools to get started, and they'll just go crazy. That's one of the things that I've talked to one of the robotics teachers that I work with. She says, my students know more than me about this stuff, and that's fine. She's like, I'm just there to open the door, turn the lights on, make sure they got their robots, and let them go. And they, once they get started, they do the programming, they do the design, and I just step back. And so part of it is for teachers, this can be a really scary experience to let the students be the experts and being able to be a facilitator and help that, give them the tools they need and then step back. Yeah, that's challenging. That's challenging for anybody to do, to kind of step away like that. But I think, but like I say, at least kind of the folks that I've talked with, that's what you'll often get, is that the kids are ready to go. You give them whatever tools, and they'll do it. It's just a matter of kind of making sure the adults know enough to feel comfortable and, answer what questions they can, and then helping the adults let go and let the kids just do it.
Yeah, I think you're right. Actually, it's more like a challenge for myself. Assign a variable in LabVIEW is such a different experience. So
yeah,
I would get left behind by the kids pretty quick.
Yeah. See, no, it's definitely a challenge. So we try and keep up with them the best we can and kind of send them off, and then they'll run into the same thing when they get older, I guess. But cool. Thank you very much.
Well, I don't think we have any questions down here, but we can we could all give you a big thank you for supporting us and giving us all of this creation. And answering
Yay, you're welcome.
But we're having fun this week. We've got a bunch more folks trying to work on version 1.5 of the Cellbots app for the Create. We've got a Vex Create monster mashup going, and a lot of stuff going on down here in Mountain View.
Oh, cool. Well, yeah, like I say, it's been a pleasure working with you all. Certainly, let me know if there's anything else I can do to help. But yeah, you guys have done awesome things, and I look forward to seeing more.
All right.